All right. This is to help clarify the assignment if you go with a covalent molecule on this one, okay? So remember, look through these learning targets, all right? So let's pick a covalent one. So if we look at a periodic table and close this one, remember this, that was for electronegativity. So we need nonmetals, right? So again, go back, look at the POGL. That would be a good place to start to look for an example of one that's covalent. So I'm going to go ahead and pick phosphorus and bromine. All right. So these are two nonmetals. Okay. And it's very similar. So if they're nonmetals, that's covalent, which means they're going to share electrons. So the first thing I need to figure out is the chemical formula. Okay. So in order to figure out the chemical formula between phosphorus and bromine, I know that there's going to be 3 bromine atoms. So how do I figure that out? So I draw phosphorus, go back to my periodic table, right? 2 nonmetals. This guy has 5 valence electrons. This guy has 7, right? So if it has 5, 1, 2, 3, 4, 5, I'm spreading my electrons out. So the Lewis dot structure for covalent is different. Okay, so now I have a bromine atom. Each bromine atom has 7 valence electrons. I'm drawing 7. They share electrons. So if they share an electron, they're going to share this electron and this electron between them. And go ahead and draw, should be a straight line, a bond. This line represents 2 electrons. So we know with covalent, we've got this guy called the octet rule, right? Which goes back to the same concept with ions. They want to be stable. They want to have that noble gas configuration of 8 valence electrons. So when I count how many valence electrons there are in bromine, 1, 2, 3, 4, 5, 6, this line counts as 2. So that's 7, 8. Bromine is happy. It has how many valence electrons it wants. Phosphorus, 1, 2, 3, 4, 5, 6. So we're not there. So let's add another bromine. Another bromine. 2. Oops. Need that R, so it's a different element. Bromine is still happy, right? The second bromine. Because it's got 1, 2, 3, 4, 5, 6, 7, 8. Okay. Is phosphorus happy? 1, 2, 3, 4, 5, 6, 7. No. So let's add one more bromine. Yay. Know that bromine's going to be happy, just like the others. Is phosphorus happy? 1, 2, 3, 4, 5, 6, 7, 8. There you go. Perfect. So now we've just explained the octet rule. We've drawn the structure. So how do we write the chemical formula? That is going to be our ratio. Every molecule of potassium or phosphorus bromide is going to have 1 phosphorus atom and 3 bromine atoms, right? So then I write that. So unlike with our ionic example, where it was a 1-to-1, we have a 3-to-1 ratio, right? 3 bromine atoms to 1 phosphorus. Okay, so that's what I would be looking for there. What else can we talk about? Again, electronegativity, right? We can look at the differences in electronegativity. They're going to be close together, which will tell us that it's a covalent bond. But we also know just by the definition, covalent bond. Let's look at polar versus nonpolar molecules, okay? When something is polar, we're looking at the electronegativity of the overall atom. So we'll first look at the electronegativity and the bonds and determine whether it's a polar covalent bond or a non-polar covalent bond. Okay? So the first thing we need to figure out is which is the more electronegative atom. Okay, so we go back to that periodic table we went over in week 2. Even without looking at this, I remember my trends. Bromine is more to the right, so it's going to be more electronegative, right? We draw these arrows towards the more electronegative atom, right? So each of these bonds are polar covalent, right? Because it has to do with the electronegativity difference in those bonds. All right, so each of these 3 bonds is polar covalent. If it was non-polar covalent, it would tell you that the electrons are shared almost equally, but they're not. It means we're going to find the electrons more around bromine because it has a stronger pull. It wants more electrons, okay? So that tells us the bond. What about the molecule? Well, let's take a step back and remember Vesper theory. So when I draw this guy, I need to draw it more like this. And the reason is these lone pair electrons on the phosphorus need more space. You have to space everything out. And this becomes important when we're going to determine whether the molecule itself is polar covalent. So if we look at these arrows that I drew, for the bond going towards the more electronegative atom, what does that tell you? Right? They're all pulling this way. Their overall pull is going to be down and away. That means it's a polar molecule, right? The forces of electronegativity go in a specific direction. It's the same with water, right? The more the electrons are around the oxygen atom, okay? So remember, that would be additional information if you picked this guy, right? You could talk about these. Is it a diatomic molecule? Di means 2, so no, because it's 3. You could talk about the fact that it's not a diatomic molecule and why. I'd be fine with that. Now you can talk about the bonds themselves. Single, double, triple, right? Let me grab my charger. We have no triple bonds. They're all single bonds. So a single bond in a covalent molecule is going to be 2 shared electrons. So you could talk about that. All right. Vesper theory. You could talk about Vesper theory, why it bends into the shape, right? Bends it into the shape because of these lone pair electrons on phosphorus. So how you choose to present that information, bullet list, paragraph, whatever, it just has to be short, right? I'm not looking for you guys to write a book. I'm just looking for understanding. Okay. So let me know. So hopefully this explains in a little more detail. With these, I'll have a checklist of things. Rather than putting them on one document, I'll put them into 2. Okay. Hopefully that helps, guys.